Okay, data analysis in a nutshell. When it comes to collecting good data, it depends on how you set it up to begin with. If you don't set up your trials and your experiment properly in the first place, you're not going to get good data. So you really have to think about a few things. Now, you've had it rammed into you, independent variable, dependent variable, and control variables. Now, they're really important. You have to know them, because if you don't know them, you can't set up your data analysis properly. It all comes back to that. So the example that we've used in a lot of videos is cost a good indication of quality of detergent in dishwashing detergent? So you have to think there, what is my independent and what is my dependent variable? What am I going to be changing in order to answer that question? And what am I going to measure? Well, is cost tells you what your question is about. Is cost and how that changes going to affect something else? So the thing here that we're going to be looking at and changing would be cost. That's my independent variable. Is cost a good indication of quality? So does cost affect quality or tell us what the quality is? So quality is what I'm going to be measuring. That's my dependent variable. Now, how I'm going to measure that is actually going to be up to me, because how do you measure the quality of a dishwashing detergent? There are several different factors, and the one that we chose was how much oil it broke up when it was mixed. So how much oil it reduced when you mixed it with water. So that's effectively what we're going to be measuring, and we're going to be measuring that in milliliters. And of course we're going to have different brands of dishwashing detergent, all of which have different costs. And we need to actually go and collect data on that. So when you set your tables up for this, there's a very simple method. First of all, one way or another, the independent variable has to go on one axis and the dependent variable has to go on the other. And I'll show you a couple of examples that do both ways. But to start off with, you've been taught that your independent variable goes down and that your dependent variable goes across. And that's a pretty simple way of setting it up. So you have all of your different groups down here, and in this case it'll be cost going down here, and usually we do them from either small to big or big to small, doesn't matter, but if you order them it actually makes it easier to put them in a graph. And my dependent variables, which are what I'm measuring, are going to go across here. And you have to think, what are you going to be measuring too? I mean, if you want to measure how much oil you've broken up, so say you started with 10 mil of oil and you're looking at how much is left over. So that's my starting, how much is left. How am I going to figure that out? And do I really want to know how much is left or how much it actually chewed up and got rid of? Am I wanting to know what's left or what was removed? You have to think, how are you going to figure them out mathematically? And to do that, you have to collect what we call raw data. Usually, you end up collecting more than one piece of data. I'll show you here in this example. So here we've got it set up. I've got my independent variable groups down the side here. I'm changing the cost, so there's my total cost. Notice how I haven't put dollar signs in front of them there, because if I did that, it would then start to see this as text and not numbers, and it wouldn't graph them the same way. And across here I have my dependent variable measurements. Now, first of all, realize that we have to have more than one trial. Okay, you have to do each group more than once to make sure you're actually methodically and properly and fairly testing it. So you actually have to repeat this over and over again, but for now we're just going to focus in on what I collected for one trial so you can figure it out. Now, I wanted to find out how much oil was actually being removed by each type of detergent, because I figured that was a pretty good measure of how good the detergent was, how much oil it removed. In order to find that out, I have to know how much oil I started with, how much oil I finished with, and find out the difference. And that's the sort of thing that you've got to think about when you're thinking about, what do I have to collect? And that's why we often have these raw data tables here, because you actually have to collect a lot of little pieces of data to get to the information you want. You need to collect your initial amount of oil, your final amount of oil, and then figure out the change. And you have to do that for every single trial, which means you have to have a column for all of those ones and a column for every single trial. Okay, so you've got this repeated for every trial all the way along here until we get to the end. So it ends up meaning that your data tables, the raw data, actually gets quite big and quite hard to manage if you don't set it out properly, essentially. Now, once you've got that, you've got to actually start to analyze it. So I can't do anything with the initial and the final. I need the change. In order to do that, we have to know some Excel formulas or basic mathematical formulas. How do you find the change of anything? Well, it's going to be, in this case, what I started off with minus what I finished with is going to be my change. Now, for Excel to do this, you can do this quite quickly. You can actually type in a few things which basically tell it the pattern of how to figure it out, and then use that pattern across all of your formulas for this one here. In other words, you only have to type it in once. Look at this. Equals. Now, I'm not going to go 10 minus 9. I know that's how I'm going to figure it out, but I'm actually going to direct it to the cell. So here I'll actually say the cell that's 2 to the left of me, B4, minus the cell that's just on the left of me, C4, and then go equals or enter. And it will work it out. But in its head, it's thinking the one that's 2 to the left minus the one that's 1 to the left equals this one. Now I can take that pattern and it will copy it down for me. So see what happens when I do this with my little cursor? See how it goes to the black? You take that, hold your key down, your right mouse down, and then copy it down or pull it down like that. And I'll start to do that. And that means it's copying the pattern of what you told it to do there. Let it go. And it will do exactly the same pattern, but in this case applied to the others. Now if I double click on each one of these cells, it'll actually show me how it's figuring it out with color coding to boot. Double click and it will show me how it has figured that out. Now I can take that same pattern and copy it across to all of these guys. So if I go here, highlight it, and then go copy, it won't just copy the numbers, it will actually copy the pattern, not the numbers. Unless I tell it to just paste in the values, it will actually always copy the pattern of how you've told it to do this. So if I go over here and go paste, my normal paste will just paste the pattern. See how the numbers have changed? If I tell it to paste just the values, then it will actually copy and paste the values from that previous one, but I don't want that. I want the pattern. So your very first paste option will simply paste the values or the instruction on how to actually do that calculation. Oops. Okay, and we'll do that for all of them.